Good afternoon, everyone. Welcome to another City and Guilds math lesson. I am Tamika Lodge Fenton, and I will be guiding you through today. We'll be focusing on ratio and proportion. Let's begin. So ratio and proportion, the unit is aimed to help you understand how to read and use scales as well as ratio and direct and inverse proportion. But for today's session, we'll be looking at reading and using scales on maps and plans. All right, there are a few key terms that we will review before we get into today's lesson. Ratio. Ratio compare values. Proportion compare ratios. So this is pretty much just a simple way of looking at ratio and proportion. Now, what is a ratio, or what are ratios? A ratio is a mathematical way to compare values. There are some important rules to guide us when we're writing or using ratio. For instance, order matters. Values stay in fractional form. Now, let's look here. If I want to give the ratio of triangles to circle, it could be written in several forms. But let's look. So whatever value represents triangles must come first. So as you can see, you have 4 blue triangles and 2 orange circles. So my ratio is 4 to 2, or as a fractional representation, 4 twos or 4 halves, 4 to 2, same thing. And then of course you could remove the colon and use the word 2. All right, and you can see it right there. All right, let's just look at some real world math. So ratios are used to compare 2 or more quantities in a variety of situations. These situations include baking, mixing cement, diluting concentrated liquids such as cordial and weed killer. We probably know weed killer as pesticides. The cordial, it's a little bit thicker than syrup, but it tends to be fruity. And we use it, it gives a ratio on the bottle and on how to mix it. All right, in each of these situations, the proportion of one ingredient to the other is stated, and it should be followed every time. Now, the cordial may not be that bad if you use a little bit more. However, let's say the weed killer, you should stick to the procedure, to the ratio that's given, because you're talking about dangerous chemicals and other things that you'll use. All right, so let's look a little bit more at ratio and proportion. Ratios are used in everyday life and can help you work out problems including scale drawings and reading maps. Scale drawing, what do I mean? All right, so all dimension has been reduced to the same proportion. So let's look. If you're going to build a boat, so you are a boat builder. Don't know if that is the right term, but you build boats. You pretty much need to put that model on paper before you just go out there and buy material and see if everything works. So you scale it down pretty much. You scale it down so it can hold on a simple, regular letter size or whatever paper you want to put it on. But you can have it on something that you can look at the specs of it and decide if you want to make a space bigger or smaller. And we'll look more at it. Here it says a model boat is made to a scale 1 to 20. Now 1 to 20 means that any unit can be applied, whether it be a millimeter or centimeters to the 1. Now what that means is every time if you're going to apply a millimeter, wherever you see 1 millimeter on the scaled drawing, it represents 20 millimeter in actual measurement. And if you were to use centimeters, it simply means 1 centimeter length on your drawing represents 20 centimeter length on the actual boat. All right. So scale drawing and scale models. Let's look a little at that. Scale drawings and scale models use a stated ratio for the drawing. They are used in many different situations where it is important to plan or design something before making it. Let's just look at the work that would have been put into the bus park, all that elaborate design. Now, you must think that an architect would have put this on paper before going out there and making that awesome bus park in Half Way Tree. it is important to put it on paper before you go out there and waste material and waste time and money and energy and all of that. So it is important to understand scale drawing. Now, plans of a room help design the layout of the furniture. You're talking about schools. If you're making a school, you pretty much have in mind how many students you'd like to hold in a classroom. You look at the desk and chairs that you're going to use in that classroom. And if you can figure out what is the capacity of that room, you can pretty much tell the area, the dimensions that that room has to be to hold a particular number of students. So of course you see how scale drawing is very useful in our everyday life. Plans or models of buildings show exact details of the sizes of walls and windows. What do I mean by that? We'll talk about it a little bit. Diagrams and models of machines show their shape and size compared to other objects. So when they're looking at, let's say when they're looking at a machine in a big old factory, they can tell by scale drawing how the machine will look beside a human or beside another machine. So it helps you to understand the space that you have working with and how that space will accommodate a machine that you are planning on either making or buying. A scale drawing is exactly the same shape as the real thing. So you're not going to draw a boat that looks lopsided and not too well, and then you're going to just go out there and make an awesome boat. You're pretty much replicating what it's going to look like in reality. It's just smaller, it's just been scaled down. And of course we do scale up, you know. So if you have tiny microscopic things, you may scale up the drawing. But we're looking at scale down for today. Making a scale drawing is like shrinking an object many times so that it can be shown on an ordinary piece of paper, which I already said, so pretty much we're just repeating that. The sizes shown on the scale drawing will be in the same proportion as in real life. What does that mean? All right, so if a window which is half the length of a wall in real life a window which is half the length of a wall in real life will also be half the length of the wall on a scale drawing. The proportions must match. They must be scaled down just as if you were looking at it in reality. It is important as it means that the layout of the room on a scale drawing will work in real life. And people use this every day. Architects, designers for different places, they use it. They use scale drawing all the time. And other persons. All right, so we're going to look at using scales on plans. Our first example or scenario for the day. A scale on a plan is 1 to 50. A wall measures 3 meters in real life. How big should this be drawn on the plan? So let us go to the board and look at this. So we have the scale that we're working with is 1 to 50. Now, they mentioned that the wall is 3 meters, right? How big should this be drawn on the plan? So for every 1 unit, it represents 50. It could be millimeters, it could be centimeters. For this instance, we're going to be using centimeters. So that means for every 1 centimeter, it represents 50 centimeters. All right. Now it says the wall in real life, actual size of the wall, actual wall is 3 meters. Now, I would change the meters into centimeters so I can get a better understanding of how many centimeters I'm looking at. To change centimeters to meters, you should know that 100 centimeters make 1 meter. So, 3 meters is the same as 300 centimeters. So that's information I have. So I can now equate 2 ratios. That's one way I can look at it. So I have 1 centimeter to 50. And I want to find out how many centimeters I will need to have 300 centimeters. I can now represent it as a fraction And then I'm going to use x in place here for my unknown. All right. So I will now cross multiply to figure out what my unknown is. 50 times x is 50x. And 3 times 1 is 300. I want to find x. This is 5, so it's 50x. And I'm going to divide throughout by 50 to make x the subject of this math sentence. 50 into 51, 50 into 51, leaving x. 300 divided by 50 is 6. So what I'm saying, x is 6. In other words, 6 centimeters on the map will represent 300 centimeters in actuality. So 6 centimeter will represent 3 meters. All right, so that's one way I could have worked it. Let us look at another way you could have gone through working this problem. So we have 1 to 50 means 1 unit represents 50 units. And we can say that 1 centimeter represents 50, or we can say it's half a meter, because 50 is half of 100, so it's half a meter. The wall is in meters, but I am sure it's not in meters on the plan. Why? Because meters would be a bit much to put on the plan. So we're using centimeters as we did on the board. We know that 100 centimeters is equivalent to 1 meter, and we can pretty much work down with the problem. So if 1 centimeter is 50, 2 centimeter is 100, and then 3 centimeter would be 150. 4 centimeter, you could add another 50 to it, and you could add until you reach 300. We've cut it short here because you must be familiar with numbers. You must be aware of numbers. We have 3 to 150. So 3 centimeter to 150 centimeter. You should know that 150 is half of 300. So if I were to double the ratio, 3 times 2 is 6. 150 times 2 is 300. So right there, by just doubling the ratio that I would have had, I can now reach 6 to 300, which will tell me that 6 centimeters on the plan would represent a 3 meter window. All right? All right, let us explore ratio and proportion a little bit more. The ratio of girls to boys is 2 to 5. If there are 20 girls, how many boys are there? All right, so let us see what we have here. The first ratio we have, and it's girls to boys. So for every 2 girls, you have 5 boys, correct? Yes. Now, we know that we have 20 girls. We are unsure how many boys we should have, you know, sticking to this ratio. So we can look at the relationship. So let us just look at the relationship a little bit. What is the relationship between the 2 and the 20? So you had 2 girls, now you have 20 girls. What would have happened to 2 to make it 20? 2 into 20 goes 10 times. So if you multiply 2 by 10, you get 20. So that's what it means. So that relationship must also exist with the 5 boys to get the number of boys that should be there with the 20 girls. All right? So here we go. 2 multiplied by 10 gives me 20. 5 boys multiplied by 10 gives me 50 boys. So that means keeping the ratio 2 to 5, girls to boys, when you have 20 girls, you should have 50 boys in keeping with that very same ratio. All right, so we're here now looking at a part of a map. So we want to find the actual distance. So using a ratio and scale given, so we have ½ inch is equal to 3 miles. So what does that mean? It means that for every ½ inch on this diagram, on this map, it is 3 miles in actual distance. All right, what is the question here? What is the actual distance from the lighthouse to the dock if it measures 4 inches on the map? So we have 4 inches, and we want to figure out how many miles, will you actually have in real life? All right, so we have ½ inch is 3 miles. We know this. It means that for every ½ inch, you have 3 miles. Now you can ask yourself this question. How many ½ inch can you get from 4? And as you can see here, you would divide 4 by half, giving you 8. That means that there are 8 groups of ½ inch in 4 inches. Therefore, 8 multiplied by 3, because every ½ inch is 3 miles, gives you 24 miles. You could also do it using proportion. You have ½ inch is ratioed to 3 miles, and then you have 4 inches is ratioed to the unknown miles, and you definitely will cross multiply to give you the value for x. So ½ x is equal to 12. I want x. I am going to multiply throughout by 2 to get x by itself, to factorize out that half. And I would have 12 times 4 is 24 miles. So 4 inches will give me 24 miles in actual distance. All right. Here we go again. We're looking at a simple design of a room. It would look like a living room or, a lounge. It has a couch, a table. What is the ratio here that they're talking about? So 1 to 50, units are the same. Remember, you usually get a ratio without units in it, but when you get that, if you're measuring in centimeters on the diagram, the other part of the ratio represents centimeter and actual measurement as well. So 1 to 50. What does this mean? For every 1 centimeter on the plan, it represents 50 centimeter in actual measurement. All right, what is the shortest side of the room? So you're looking at the room, you see 6 centimeter on one side, 9 centimeter on the other side. Simple. You know that 6 is smaller than 9, so the side that measures 6 is the short, and it should not be shortest, it should be the shorter side of the room. All right, so you have 1 to 50 equal 6 to, so you have 6 inches, 6 centimeter I should say. Now for every 1, you multiply it by 50, so you have 6 multiplied by 50 gives us 6 to 300. So on the diagram, you have 6 centimeters. In actual measurement, it would be 300 centimeter, which is the same as 3 meters. So the shorter side of the room is 3 meters. Here we go again. You need the doorway to be 1 meter wide. 1 meter, what is 1 meter? 1 meter would be 100 centimeter. All right, great. So 1 meter is equal to 100 centimeters. That's the first point. You know the scale is 1 to 50, and you need to figure out, so it means 1 centimeter to 50 meters, 50 centimeters. 100 centimeter is pretty much twice 50, right? 2 times 50. So you can either work it out in your head that it's really 2 centimeters, or you can actually add 50 and 50 gives you 100, and 1 and 1 gives you 2, or you could do the proportion where you have 1/50th equal x 100th, and you cross multiply. But 2 centimeters would represent a 1 meter doorway. Now, not all questions that you will do, you need to do any elaborate calculations. You can examine your numbers and pretty much reason out logically what your answer will be. Like this question, if you have 1 to 50, to get 100 centimeters, you just know that 50 is half 100. So if you multiply it by 2, you get 100. And if you multiply one side by 2, you must multiply the other side. So it becomes 2 to 100. All right, guys. Let us look at this question before we go into our exam questions. A model of a new airport has a scale of 1 to 5,000. On the model, a runway has the length of 80 centimeters. What is the actual length of the runway? All right, so we are here now. The scale is 1 to 5,000. So it's a bigger scale. It's just bigger numbers, but we can do this. So you have some options here. There you go. Great. Let us go to the board and see what we can do here. So the first thing you're given is a scale of 1 to 5,000. By now, you should understand that the runway is in centimeters, clearly, because you see 80 centimeters there. And you know the airport is a large area, so you can understand why you have that 80 centimeter. So you have 1 to 5,000. It says the runway, so that means you have 1 centimeter will equal 5,000 centimeter in actual measurement. All right, so we can do one of two things. How do I make this 80? I can say 1 multiplied by 80 will equal 80. Now, if I multiply one side by 80, I definitely will have to multiply the other side by 80. So this is so I will get 80 centimeters here. And let me take out that equal sign not to confuse anyone. All right. So 5 times 8, that's 40. And we'll put back all of my zeros that I have up there because it's like I'm multiplying by thousands. So we have, that should be 400,000. So what we're saying, 5,000 multiplied by 80 gives me 400,000. 80 centimeter equal 400,000. Now look at your options. You see 1.6 kilometers, 4 kilometers, 6.25 kilometers, 16 kilometers. This don't look like nothing that we have here. So what do we do? All right, so this is in centimeters. And as you can see, your answer is in kilometers. So we have to convert. So let's convert 400,000 centimeters to meters first. Will equal 400,000 divided by 100. Because 100 centimeter makes a meter. So that gives us 4,000 meters. So 400,000 centimeter is equal, let me put it here just to make sure we understand this is equated. So this is the same as that, but we still don't have any answers in meters. So we're going to convert the 4,000 meters to kilometers. And we do that by dividing by 1,000, because 1,000 meters will make a kilometer. And that gives us 4 kilometers. So 4,000 meters is equivalent to 4 kilometers. So your option would be option B. So remember, guys, when you have a question, look at the units, your answers, your options are in. So when you do your calculations, you can know if you must convert to a different unit in order to get the correct option that they have given. Now, this is just pretty much going back through what we did already. So as you can see, we would have ended up with 4 kilometers being the correct response. It's that time of day when we look at City and Guilds exam questions. Let us do the first question for the afternoon. On a diagram, 2 centimeters represent 10 meters. A line drawn 8 centimeter represents, so let us look at the first ratio we have. 2 centimeters represent 10 meters. All right. So if you have a line that represents a line drawn 8 centimeters represents what? All right. So we have 2 to 10. We can now say we have 8 centimeters and we don't know how many meters it would represent. We can look at the relationship that exists. To get 2 to 8, I would multiply it by 4. How do I know that? 2 divided into 8, 4 times. So 2 times 4 gives me 8. If that is the relation between the 2 and the 8, that relation must also exist with the 10 and the unknown figure. So I can easily multiply 10 by 4, giving me 40. So the 8 centimeter will represent 40 meters in actual measurement. All right. And that would be option C. Great job. I hope you guys got it. Next question. On a map, 1 centimeter represents 2 kilometers, right? So what is the distance? What is the distance represented by 6 centimeters? Let's look at that. What is the ratio? 1 centimeter to 2 kilometers. That means now I have 6 centimeters, and I would like to figure out how many kilometers that would represent. So what's the relationship with 1 and 6? 6. 1 times 6 give me 6. So 2 times 6 will give me 12. So my correct response here is for every 6 centimeters, it will represent 12 kilometers. And my option would be option A. That is excellent.